Hi, I'm Harry Reynolds with Juniper Networks. Been here quite a while, about 20 years or so. In that time frame, I've written a few books, done some training, some certification work. About a year ago, I joined the Contrail team on the enterprise side, so kind of an old dinosaur getting hip with it now. If I can do it, I reckon anyone can, and I think that's why they sent me along. They told me to do more demo and less talking, so we'll get on with that. Today, the primary focus is to show you how Contrail Enterprise can manage the complete life cycle of a data center. As James had mentioned, the key here is engineering simplicity, abstracting away the complexity, allowing you to focus on what needs to be done and not how to do it. So as part of that, we'll quickly look at our demonstration topology. Then we'll stand up a data center, what we like to call a day zero activity. We're going to go from ground zero to operational EVPN-VXLAN, which is always a mouthful to say, in about 5 minutes. Maybe somebody can time it and keep me honest there. Then we're going to use the data center for its intended purpose, which is to set up logical connectivity. We're going to do some L3 or routed connectivity between some servers. And then we're going to talk about how we can also manage the maintenance or upkeep aspects, what we call a week one activity in your data center. With that said, let me quickly give an overview. I know James had already captured a lot of this, but I'm going to work bottom up, sort of defy convention here. Juniper makes a fine series of QFX switches, industry recognized, 10 gig to industry leading 400 gigabits, both custom silicon as well as merchant silicon, depending on the platform you choose, well suited for data center fabrics. As James had mentioned, he did such a good lead in for me. EVPN-VXLAN is considered the current best practice for a data center fabric. It's used by the largest hyperscalers on earth, industry standard, multi-vendor, high performance. Greatest thing since sliced bread, except it's somewhat complicated. BGP in the data center, there's some resistance, if you will, to deploying new technology. You don't need a controller to deploy an EVPN data center. All you need are QFX switches and people that are smart enough to program the CLI to make the EVPN thing happen. Where the controller steps in is to make that simple. So Contrail Enterprise Multi-Cloud, very quickly, it's a collection of 3 software products combined together: Contrail Networking, Contrail Security, and our telemetry solution. We now call that Contrail Insights. Some of you may know it as AppFormix. All of that's brought together through a common graphic user interface known as the Command UI, which we'll be showing shortly, which provides your single pane of glass into the operation and management of your network, and that includes, of course, the telemetry. So the whole goal of using a controller is to make it simple, agile, and less prone to human error. We want to be able to implement adds, moves, and changes quickly. We want to reduce the likelihood of human error creeping in to cause problems, and we want to make it easier to troubleshoot should anything actually happen. Once your data center is up and running, we're going to abstract the complexity of how to use the data center, or program it, if you will, and allow you to focus on the intent. I want this device to talk to that device, whether it be a physical server, a containerized workload, or a virtual machine. This is completely programmable. If you're the type of company that wants to do all of this through scripting or automation, DevOps, if you will, that is, of course, possible. We have published all of our APIs. I'm not quite that smart, so today you'll be seeing me use the graphic user interface, but for every mouse click, what have you, there's an API that would be the equivalent. A big part of the solution is the telemetry, and it's evolving artificial intelligence, machine learning, closed loop automation, where we not only alarm and report issues, but will ultimately be able to take action, corrective action. Rather than waking up to a trouble ticket, you might wake up to an indication that something seemed to be happening and we've taken corrective action. So now all you have to do is figure out how to resolve it in the background, as opposed to a fire alarm with lack of connectivity. I'm not going to speak a lot to the telemetry side because that's what my colleague Harshit's going to be speaking about. By the way, we have a natural break, about a 5-minute period when we onboard the fabric, and of course I'll take questions anytime you have them. Trying to keep this minimal lecture and more demo, but if you have a question, ask. But there is like a 5-minute break coming up shortly. So I went backwards, sorry. Always forward. Here's our demonstration topology. We have a relatively simple 2 spines, 2 leaf topology. Notice that all of these devices are connected to a common out-of-band management network. It's been given the 192.168.0 prefix that will come up slightly later. Right now, I have all of my devices factory default. I'll quickly switch over. This would normally be the last thing you would want to see waking up on a Friday in your data center. These are the QFX switches saying, I don't even have a management address. I have no configuration. These devices have been zeroized as if they came out of a box. I don't know if you can tell, but I'm on a console connection right now. I cannot even SSH into these boxes. So right now, they're all asking for an IP address and looking to get bootstrapped, if you will. And in a moment, we're going to ask the Contrail controller to respond to those DHCP requests, get them configured, get the BGP underlay provision, get the EVPN overlay provision so that you can get on to whatever you plan to do with your data center. I'll point out quickly that we have 2 bare metal servers. They're on the management network. That's all well and fine. And this is the fabric topology. We're using 40 gigabit interconnect for the fabric links. Not much else to point out here except in the case of our 2 servers, notice that bare metal server 1, which we call the web server, is attached singly home to leaf 1, happens to be using XE10. Bare metal server 2 is connected to both leaf 1 and leaf 2, happens to be XE9. So server 2 is multi-homed, and that's going to allow us to demonstrate EVPN multi-homing. And also some of our maintenance mode capabilities once we get to that stage. So with that said, I guess it's time to bring up our fabric. You'll excuse me a minute. Used to be when I did this stuff, I didn't need glasses. Time moves on, right? So this is the command user interface. This is Contrail command, your portal to the solution. Common pane of glass, logging in. I'd like to point out we're on release 1912. That's about a 2-month-old release at this particular stage. This is production code. Everything you see here is real, live, no safety net, and with shipping code. All right, so we're going to go to fabric. You'll notice we have no fabric. Look to see what's not here. So we're going to create a fabric. We support existing fabrics, which we call brownfield, and if you're the type of individual that prefers ISIS or OSPF as your IGP, that is accommodated through brownfield onboarding. I'm going to demonstrate greenfield onboarding, in which case you will get an eBGP IGP. It's a little odd to have eBGP as an IGP, but we have a really good implementation of BGP here at Juniper. And the way we implement it with things like BFD, bidirectional failure detection, et cetera, we have pretty good convergence characteristics. I wouldn't necessarily say it will beat OSPF, but in the vast scheme of things, I don't think you'll notice the difference. So we're going to move on with the new fabric. Maybe I should look at my own screen. Okay, we're going to provision that. So there's a few fields that we have to fill in, and I'll try to explain what they are. This is the name of our fabric, so I'm going to call it SEMGRU, and I've already made a typo. Maybe too many cups of coffee here. I like to have an underscore. This is the root password, the password that you expect to find in the devices. Keep in mind they're factory default. They have no password, no remote access whatsoever at this point. So should you ever need to hack into my fabric, you now know the root password. This is the overlay ASN. It's any number you want. I see no need to change it from the default. It asks you to upload a device information file, which I've just done. Let me quickly switch over to that device information file. In a greenfield fabric, we discover devices based on their DHCP queries, and then we provision them. To guard against unauthorized DHCP or rogue DHCP, we have you fill out an information file in YAML format that lists the serial numbers of the devices you expect to discover. So that constrains the discovery process. We know when we're done, for example, because we will have all 4 or 10 or 500 devices, however big your fabric might be. We do support what we call supplemental device configuration. Lots of configuration will get pushed out to these fabric devices, trust me, but sometimes there's additional configuration that you may want or desire, such as channelization of interfaces, or in this case, a lab NTP server. So I've broken it out by switch, but you can do this in a grouped manner. As you see, we have the same NTP server for all 4. I could have done that a little simpler, but I wanted to show that we can do supplemental configuration on a per device basis if desired. Notice also that we have the ability to specify a host name, so we'll be able to see leaf 1, spine 1, etc. So there's really no magic in the device information file. I just wanted to show you that's what it is, and I can now dismiss the window. We have our profiles. We do intent-based provisioning, so you're able to specify what types of nodes and what types of profiles or roles you would expect them to perform. In our case, there's no need to delete any of this. It's not like we're carrying extra baggage. Even if you don't have a QFX 5K lean today, lean meaning it does no VXLAN functionality, it's strictly an IP underlay device, you might add that later. So there's no harm in leaving this the way it is, and we do support growing or adding the fabric. You start today with 4 switches, maybe tomorrow you add a 5th. That's all accommodated by the solution. So moving along, we have to number our underlay. Again, in a greenfield, we use BGP, eBGP. So this provides a range of ASN numbers that will be assigned to individual fabric devices. Technically, we need 4. Again, this private use, it doesn't hurt to have a little extra, right? It's Friday. Moving along, and we're almost done here, almost ready to have our fabric up and running. We need to specify the IP subnet, that is the management network, excuse me, because that's where we're going to be assigning the management addresses out of so that we can later SSH and netconf, etc., these various devices. We need to specify the default gateway address so that if they need to get off of that subnet, they'll know how to route out of the out-of-band management. Nothing too complicated yet. We are going to have an IP underlay. Sorry. This is supposed to autocomplete for me, but I seem to be having difficulty. Okay, so this is where we will number our fabric links. It is an IP underlay, so we need IP numbering. And we're going to peer loopback to loopback in the overlay, which is conventional best practice, so we need to have a numbering space for our loopbacks. And there you have it. So all said and done, it wasn't a whole lot of complicated fields that needed to be entered. We have our fabric name. We've uploaded our YAML file with the serial numbers of the devices we expect to discover. We could do an upgrade during this process, because remember, these are factory default switches. It's possible that when we shipped the switch, the Junos version was less than it is today, so as part of this process, you could upgrade. We'll spare you the time of that. Our range of ASNs so that we can number the underlay, our management CIDR, and our fabric and our loopback. So with this said, I guess it's all over but the provisioning. What's provision? Oh, somehow, I don't know. I swear I have ghost going on in here. Oh. I don't know what happened there, sorry. I'm going to have to repeat this really quickly. Too many mousy, clicky, pointy things for me. It won't take long. So the good thing is you've seen all this before. I don't need to explain it. Don't know what happened there. Management subnet. So this way you can tell this is not recorded, correct? All right. So all of those fields are back. Again, sorry, I didn't know what happened. Anyway, now the magic happens. So this is sort of our natural pause. It will take about 5 minutes for this process to complete. We'll start answering DHCP requests. We'll start provisioning the fabric. And let's see, anyone have any questions, concerns, comments?
So Contrail Enterprise Manager serves as the DHCP server?
Correct.
During the discovery process?
Correct. It's using part of the OpenStack that's built into the product. What would normally be used for Ironic, bare metal server lifecycle management, we're leveraging that capability to do things like DHCP and TFTP file transfer, etc. Any other questions? I just like to monitor that things are happening. Notice that we have some indication that the controller, which was given IP address .2, has been seen by this particular device. This is Leaf 1. I am capable or able to monitor the playbook logs that are happening. Not that that's too terribly exciting, but this is the actual controller doing its business. So far so good. We've discovered one of 4 devices. During this discovery process, we first discover them, then we provision remote access to them, a root account with netconf and SSH. Then we go into the role assignment phase where you tell the software what roles you expect these devices to perform. Are they leafs? Are they spines? Is it a lean spine, etc.? And that's when we'll see the overlay underlay come out, and that's in the next screen. Notice that our interface count is currently 0. Once we onboard the device and can get to it remotely, we'll start doing show interface to determine what interfaces are present. We have boxes that support hundreds of interfaces, and they can be channelized down into sub-interfaces. So to speed this process up, we only onboard interfaces that are found instantiated or active, which for most switches means there's an SFP optic install. We do support a function where you can rescan the device later. So you could start off with 4 interfaces or 40, and later if you add another 100 interfaces, which is to say put more SFP modules in, you can rescan the device and we'll re-onboard any updated or Delta interface. Things are looking pretty good so far. Give me a few more minutes. I don't know if anyone's timing this, but let me reiterate. You're starting from factory default, no configuration, and you're going to end up with an operational EVPN data center fabric. So, indulge us if it takes 5 minutes. Any other questions?
So what's the process for actually deploying the Contrail Enterprise Manager itself?
Do you mean like the installation of it? Well, we're working on an OVA solution, which will make that easier to install, but basically you need access to the Juniper registry, which you can sign up for, and you install it. First, we typically install the command server, and we can do this all through Ansible, but generally speaking, it's done in a graphical user environment. So first you install the command server, and then you use the command server to provision the cluster, and then you say do it, and then about 50 minutes later, you either have spectacular failure or you have an operational cluster. Installation is a little tricky with this platform. As you saw, I couldn't even type 4 variables without screwing up one of them. And that's why we're working on an OVA.
When do you think that might be available?
I heard, don't quote me on this, but I'm hearing second quarter of this year.
All right. Sorry, the reason I ask is we're actually deploying that within the next weeks.
All right, well, we can help you with that. If no need to wait for the OVA. Notice we do see our interfaces. We're now in an onboard status. We're almost ready to move on.
So for the greenfield, you're running eBGP between?
We are.
So if the customer wants to change the default behavior to IGP?
Then they need to do a brownfield onboarding.
Okay.
Which means they would have to pre-configure their IP underlay using OSPF or ISIS. Basically, they need to have reachability between loopback addresses. They don't need a loopback address. We'll provision one as part of the overlay, but if you do configure a loopback address, then we'll use what you've configured. We'll onboard it, sort of ships in the night. It's opaque to us, the underlay. As long as we have reachability between loopback addresses, then we're good to go.
So you have template for that also?
I think if I follow the question, I don't know that we've explicitly defined exactly what you need in an underlay, what can or cannot be there. There are so many variables when it comes to configuring OSPF or ISIS. Personally, not personally, but as a company, we prefer the greenfield approach. To some degree, if you're going to put your data center in the hands of a controller, which abstracts all of this underlying complexity, then we might argue, why do you care, right? If it works, it works. And again, I would argue our eBGP implementation is quite fast as far as RIB, FIB, convergence, et cetera. We have some benefits with eBGP route filtering, for example. That's very hard to do with OSPF or any other link state algorithm.
Do you think it's a best practice to go with eBGP?
Well, I think at Juniper, we have chosen eBGP as the greenfield underlay IGP. And again, If you're going to trust your network to a controller, then trust us, and it will work for you. And I doubt you would see any dramatic difference if all things were considered equal between our greenfield and your brownfield. But if that's just too much heartburn, eBGP as an IGP, then there is a solution, which is to configure your own underlay.
Okay.
And that would be a brownfield. Good questions. Awesome. Okay, so green status bar, that's always good. Yay. So now we're going to proceed to role assignment, right? And we use a role-based assignment model where you specify what role the device will play in the network, and we worry about all those details for you. So notice I've selected the 2 spine devices, and I'm going to identify them as, wow, spines, right? So now we know where they are in the logical IP class fabric. Now we're going to indicate what type of role that device will play. Today, we've chosen to show centralized routing, where routing occurs in the spine, but the solution supports edge routing. If that's your preference, we'll do central routing today. We always do route reflection in the spine. BGP scales quite well via route reflection, and we are working on hierarchical route reflection as well, so that you can have massively scaled out data centers with multiple levels of route reflection hierarchy. Right now, I believe we only support the 1 level. So I've assigned the roles for the spine devices. I shall now do the same for the leafs. Biggest difference being they're leafy, very green, right? Remember your carbon credits. And this will be CRB access. So the leafs will be performing L2 VXLAN gateway functionality. The spines will be doing the L3 VXLAN functionality. I always like to double check. I've got 2 spines, CRB gateway, route reflector, CRB access, good to go. So now we're pushing out the IP underlay, or the eBGP-based IP underlay, and the EVPN overlay. It'll take just a few moments. Any other questions? Wow, this is going remarkably well. Okay, says it's done. Far be it from me to doubt it. We are now supporting S-Flow. This is something Harshit will be talking about in a few moments, but let's go ahead and configure an S-Flow profile. I won't actually be using the S-Flow profile, but just to show you that we do support attaching telemetry profiles. We have a couple of default profiles. You can customize your own as you see fit. So this should complete the deployment of our underlay overlay. While this is happening, let me just point out that we have some job management capabilities. So these various fabric jobs are being queued up, scheduled, running, hopefully completing with green status. That's always nice. Let me see if we have the ability to look at some kind of a log here. Right, so very, very detailed log. We have better logs I could have chosen. Right? I'll just view all logs here, or all jobs. So here, for example, is the log for the configuration that was pushed out to spine, or I guess I chose leaf 2. So you can see that the last thing that happened was the S-Flow related configuration going out to leaf 2. Let me go ahead and dismiss this log window, get back to our fabric, and voila. Admin. Didn't think I called it admin, but okay, I guess I did. So now we have our fabric onboarded. You can see the parameters that were provided to the wizard to bring that fabric on board. We have our spines, our leafs, they're active, good to go. You can view details about the devices, their versions, what role they're playing, etc. Any questions so far? All right, let me quickly show you one other functionality that I think is cool, and the topology view will be something that Harshit will be mentioning with the heat maps and things like that. Let me go back to the fabric here. Let me select a device, spine, it's always hard to see here, spine 1 I think it is. Please dismiss, there you go, spine 2, sorry. We have something called custom actions or device operations. We publish the specifications for this, and we give you a preset number of them, but this list is growing, and customers can write their own custom actions. But basically, this is the ability to reach out to the fabric and do CLI commands, and not just display the returning CLI data, but to massage it, to filter it, uses Jinja templates and things like that in the background so that you can make that command output useful. So I'm going to really quickly look at a configuration diff on spine 2. So what we're going to do is look at the configuration 2 iterations ago. Junos uses a commit model where you can put any number of changes into effect. None happen until you type commit, then it's either all or nothing. So what we're going to do is look at the state of the configuration 2 commits ago compared to the current configuration, and we'll thereby get a diff. Give it just a few seconds. I try to do all of this without the CLI these days. On the CLI, you'd be doing a show configuration, compare, rollback to, for example. So there's the diff. This is essentially what happened with bringing the fabric on board. This is the underlay, this is the overlay. Last time I counted it, it was about 140 set statements. So as much as I'm a CLI kind of guy, the thought of typing 140 set statements on one of the 4 boxes, it doesn't sound all that intriguing to me anymore. So quite a few changes were pushed out with a relatively simple process, as you saw happen before your very eyes. Lots of stuff there. All right, so now that we have an operational fabric, let me switch back to the presentation real quick. This is what we ended up with. We started with factory default. Within, I don't know, 5-10 minutes, we now have an operational EVPN-VXLAN fabric ready to define our services, use the fabric for its intended purposes, and we will be moving on to show some L2, L3 VXLAN connectivity. I put a bunch of parameters there just to remind us that these are the things that we specified in the wizard, the out-of-band management network, the loopback space, the fabric space. All of those values have been assigned. We can see what values were assigned using the command user interface. But who cares, right? This gets back to engineering simplicity. Does it really matter what subnet was assigned between leaf 1 and 2? If it does, then you need to do a brownfield. Otherwise, put your faith in us. And let me quickly point out that our 2 servers, bare metal server 1, bare metal server 2, they are attached to leaf 1 and leaf 2 respectively. Notice that bare metal server 2 is multi-homed to both leaf 1 and leaf 2. That's what's going to give us the EVPN multi-homing later, as well as some fault tolerance. Because of its dual or multi-home status, if we were to reboot, for example, switch 2, we could expect connectivity to be preserved between the servers. Now we're going to use this fabric for its intended purpose, to provide connectivity. In the Contrail model and in the Juniper mantra, keep it simple, stupid, right? Engineering simplicity. This is going to involve 3 abstract concepts: virtual networks, virtual port groups, and logical routers. But don't worry, it sounds complicated, but it's really as easy as 1, 2, 3. First, we're going to define 2 virtual networks, one for bare metal server 1 and one for the other server. This is essentially analogous to a broadcast domain. We're going to say there is a network, it's given this name, and it has that subnet, and this matches the addressing that have been shown on the previous slides. Not very difficult until I try to do it while I'm talking at the same time. Then we're going to bring in a logical router. Now we are showing layer 3 or routed connectivity. That's why we need the logical router. If this was strictly a layer 2 broadcast domain, you could skip step 2. This is analogous, by the way, in Junos to a virtual route forwarding table, a VRF. I suspect you're quite familiar with how VRFs are used in L3 VPN service provider networks. Pretty common concept, but the net result is we're going to define a logical router. If I don't fat finger it, it'll be called web to app logical router to represent the fact that this allows the web tier to talk to the application tier. We're modeling a 2-tier application here. And because both of these virtual networks will be confined within one logical router or one VRF, we will have inherent connectivity between them. Notice that each virtual network will get a default virtual gateway gateway address, as it's called. In this case, both spine devices will be configured the same IP address and a virtual MAC address. So from the Leaf's perspective, I'm forwarding to my default gateway. I don't know if that's in spine 1 or spine 2. We do some sort of load balancing hash. So in theory, we're going to be using both spine 1 and spine 2. But if we should lose a spine, the Leafs won't even know because the IP address remains the same, the MAC address remains the same. Everyone good with this so far? All right, so, the astute observers in the audience would quickly notice we have everything we need except the devices that communicate. So the last step is virtual port groups. This is the concept that we use to describe how a workload attaches to the fabric. That's essentially what switch, what port on that switch, or ports. And by the way, we support N by connectivity. I've heard some vendors are limited to 2 attachments at most. We can support 10 attachments. You could have the same workload multi-home to 10 different switches if you needed the capacity, the better load balancing, or the fault tolerance. So the last step in the process is to define what switch, what port, and what VLAN and or tagging method is being used. Once that is defined, you have everything you need for connectivity, right? So back to the demo. I think you'll remember it was a 3-step process. Step 1 was what? Virtual networks, right? So I'll go ahead and create these virtual networks. I believe the first one was the web tier. By the way, notice for this default and admin up here, the solution supports multiple projects or domains, multi-tenancy, if you will. So you could actually create a domain for a subscriber or a tenant, and they're able to manage their own portion of the data center. In our case, we only have the default or single domain, which is called default. So I now need to identify the subnet associated with that virtual network. And notice I'm picking the default domain. It's the only domain we have. But again, we support multi-tenancy if needed. I'm going to see if I can type in the address correctly. You never know with me. Notice by default, we set an auto gateway and it's host identifier 1, as we saw on the previous slide. We don't need DHCP, although it is supported. Likewise, DNS. I have static configuration in my bare metal servers. So, virtual network created. In this particular, in this action, no changes are pushed out to the fabric. Simply defining a virtual network does not require anything be pushed out to the fabric. We need those other pieces, step 2 and step 3, before something actually happens in the fabric really quickly. And you've seen this before, I know. I'm trying to speed it along. So this is the subnet for bare metal server 2. Likewise, we don't need any DHCP. We don't need no stinking DHCP. So step 2. Anyone remember? Logical router in our case. You could define the virtual port group now if you wanted to, but by defining the logical router, you ensure that there is no period of time that these devices could have inadvertent connectivity. In other words, before we attach the workload, we're going to define the safe sandbox that those workloads will ultimately live in, so there could be no chance, again, that anyone talks to anyone, even if it's only for a few moments. That's why we consider it the best practice to do the logical router next. We have no logical routers, not a problem. We'll create one. Why don't we call it the web to app logical router, right? Why not? We have to specify where those logical routing functions will exist or live. And in our case, we're doing central or spine-based routing. So we're going to push this logical router out to both of our spines, given as fault tolerance and load balancing. We have to specify what type of logical router. VXLAN routing means a VRF. We're going to create a VRF in the spines, and we're going to put these 2 virtual networks in it. What 2 virtual networks? Well, our 2 virtual networks. So there you see the web and the app tier virtual network being linked to a logical router, which in turn is pushed out to the 2 spine devices. You could manage explicitly the VXLAN network identifier. Generally speaking, put your trust in the controller. We'll pick a VXLAN ID that is not being used. Trust us. But we do allow you to manage your own VXLAN numbering if that's important to you. So with this said, we'll click Create. because I'm a multimedia kind of guy, I'll switch back to the controller, and we should see changes going out, because this actually involves something. This is putting a VRF into the spine device. I know, not the greatest thing. While this is happening, let me quickly go to bare metal server 1 and point out that it can't ping bare metal server 2 because we're not done yet, right? We have that third step remaining, bear with me. And I can also just quickly point out that it does have the IP addressing that we've been talking about, right? So with this done, now we've got our logical router. The third step is to attach our workloads with virtual port groups. We don't have any. Again, this was brand new. This data center just got born like 10 minutes ago. What do you want, right? Well, we want it to hurry up and grow up. So let's give it a name. We'll call it BMS1. So we'll start with the port group for the first bare metal server. I'm sequential like that. I remember now somehow I named my Fabric admin. Who would have figured? Keep in mind, your data center might have 500 switches. There could be hundreds of interfaces on each of these switches, so we do offer the ability to filter by switch. You can also filter by interface name. You could just type in XE whatever, and we'll find all of those XEs. So in our case, for bare metal server 1, we're connected to leaf 1, and we're going to be using XE10. There it is. So we've defined what leaf and what port on that leaf. And we're almost ready here. We have to associate that to an actual virtual network, and we identify a VLAN. We have a one-to-one mapping between VLANs and virtual networks in our default operation. And in my particular case, my bare metal servers are not using tagging, but we do support trunks or tagging if need be or if desired. So that said, we've created our first virtual port group. So changes are now being pushed out to leaf 1. That's the leaf in question here. We're going to be configuring the VLAN, the VXLAN connectivity. This is where it really happens, right? But you believe me. So let's move on and define the second virtual port group. As you might have guessed, given my propensity to fat finger, this is BMS2. We have the same fabric. We do support multiple fabrics with this solution. BMS2, remember, is multi-home to multiple switches. I'll start with leaf 1, XE9. Then I'll quickly filter over here to leaf 2, and conveniently enough, same interface. So this alone is all that you need to specify to get EVPN multi-homing. I think that's pretty simple, frankly, if you've ever had to configure EVPN multi-homing. I'll associate this with the application tier. We're using or associating that with VLAN 200. And again, we are untagged. All right, so coming back over here, you remember there was a time when BMS1 could not ping BMS2. That time continues, even as we watch. But I have faith in the controller. The controller's doing its work. It's pushing changes out to both leaf 1 and leaf 2. Gives me an opportunity to sip some coffee. It's all or nothing. Come on. Any questions?
So the controller is using netconf?
It is using netconf. Or should be.
I saw on one of the displays, there was a box checked for NAT.
Yes, SNAT or something. We're not using any SNAT, but it is supported. There was, I think there were two options. One in the VXLAN router type or the logical router type. Oh, good. Whew. You know, trust me. Yeah, we do support NATing, functionality like that. It's not my plan to demonstrate it today. All right, so we have connectivity now between bare metal servers. I mean, this is spectacular. Think about it. We started from scratch. We now have an operational data center with L3 VXLAN connectivity. Awesome. Let me start a rapid ping between bare metal server 1 and bare metal server 2. I'll explain why in just a second. I'm here at leaf 1. I told you I wasn't going to use a CLI. I don't have to use a CLI. I choose to. I'm a CLI kind of guy. I just want to get a real quick view of its loopback address. So leaf 1 is 250. Let me switch back very quickly to our fabric. I'm going to do a loopback to loopback ping. and I don't know who got what address because this is, again, a greenfield underlay. So let me look at leaf 2. Leaf 2 appears to have gotten 249. All right, I can accept that, right? Sorry. I can accept it, I just can't type it. Sorry. So this is going to be sourced from leaf 1. And we're going to go to leaf 2. Sorry, too many addresses in my head. I think we said it was 250, right? We'll do a bunch of those, and we'll make it somewhat of a big ping. Bigger is better. So now we're pinging loopback to loopback between leaf 1 and leaf 2, and we're pinging rapidly between bare metal server 1 and bare metal server 2. By the way, that loss that you see, that's our inbuilt ICMP rate limiting. Don't worry about that. We're not having any loss in our fabric. All right, back to the presentation. We're going to talk quickly about where we landed, which is we now have a functional fabric. On top of that fabric, we've defined L3 connectivity through our spine devices. BMS1 sends through its VTEP up to the spine device using the virtual gateway address. Spine device receives the packet, realizes it's addressed to it at the MAC layer, but not the IP layer, does a layer 3 lookup, realizes that it's destined for the MAC address or subnet of bare metal server 2, and re-injects it into a different VXLAN tunnel. So that's where we are now, right? And we see that we've got pings flowing between the leaves as well as between the bare metal servers. So really quickly, and we're in the home stretch here, bear with me, maintenance mode and hitless maintenance operations. Now that we've brought up our day 0 fabric, now that we've done our day 1 networking activity, there might come a time when you need a week 1 type of action, such as replacing a failed switch or doing a fabric upgrade. We have a function or concept called maintenance mode, which is in turn linked to a health check or series of tests that allows you as an operator to know a priori, or at least after the self-check passes or fails, whether you can put a device into maintenance mode in a hitful or hitless manner. If it's hitful, we will not activate maintenance mode, and we will warn you, and you can therefore schedule that activity for the appropriate maintenance window. If it is deemed to be hitless, then we will activate maintenance mode, which causes AS path prepending in the underlay, effectively setting a high IGP metric, and does route filtering in the overlay regarding EVPN routes. So for all intents and purposes, the device in maintenance mode is taken out of the forwarding path. And again, we won't activate maintenance mode if that in itself is not hitless. Notice that in this demonstration, we're picking leaf 2 to do this on, and there's a good reason for that. That's the leaf that we have dual home connectivity to for bare metal server 2. That will allow leaf 2 to go into maintenance mode. The last bullet point there I think is pretty critical. Spines are easy to put into maintenance mode because of the nature of the IP class fabric. It's redundant. It doesn't matter which spine you use, one spine, the other, whatever. Leaves are a fair bit different. If you'll notice leaf 1 bare metal server 1, there is no way that we can take leaf 1 out of the forwarding path and expect that to be hitless, right? Just it would be unreasonable. So we would fail maintenance mode activation on leaf 1 unless you, of course, choose to forcefully override that action. And we would assume at that point you'd be doing that in a maintenance window. So really quickly, and this is again the final stretch, still pinging, right? Awesome. Back to the command user interface, back to fabrics, back to our fabric, the one that was born on Valentine's Day, I would remind you, so you have to love it. Let's go to leaf 2, and let's activate maintenance mode. So first I have to confirm I want to activate maintenance mode, and then this really quickly is the health check. Notice you can enable or disable it in its entirety, and then there are various things like signs of instability, excessive CPU utilization, FPC being offline, flaps occurring in the underlay or overlay, BGP peers being down. There are a number of things that we consider are indicative of whether it is safe or not safe to put this device into maintenance mode. Really quickly, let me go to leaf 2 and point out that because we care about the environment and saving trees, we don't often power up all of the PEMs or power entry modules in our devices. Somebody believes it saves energy. So we have a chassis alarm in effect on Leaf 2. And as you saw in the self-check screen, one of the options is to check for system alarms and or chassis alarms. So as default, we will fail maintenance mode activation, and I won't force you to persevere through that. So let me, God, just have to look at it. How about that? Let's disable chassis alarm as a criteria for health check. So now we're scheduling a job to run the self-check, the health check, if you will. Notice it's Leaf 2. Not quite sure yet what its status is. We'll know soon enough. It's going through all of those various checks, validating, if you will. Do we have any questions or comments?
One thing I noticed is you're doing the routing at the spine level rather than leaves. Any particular reason?
I'm a creature of habit. My drawings were based on, we do support edge routing, so we could have just as easily done this on the edges, in which case we would have a null spine or a lean spine. The spines would only be doing the IP routing and the underlay. So what does it say? Health check successful. Almost like I knew that would happen. So now I'm actually activating maintenance mode. And by the way, now we rerun the health check. Things can change in a moment's notice in a network. We might have had, less than 60% CPU utilization 2 minutes ago, but do we still have less than 60%? I don't know. We'll be among the first to know. Bear with me there. Moving along. While this is happening, just because I think it's interesting, well, I don't want to mess with this just yet. Sorry. Health check was successful again. We should soon be scheduling that DAR maintenance mode. Notice the multi-home, right? It's smart enough to know that Leaf 2 has only multi-home detachments. That's what's allowing this to pass without me turning this off in its entirety. Completed health check. The water's almost ready to boil, trust me. Maintenance mode activated. I sometimes, again, like to go to the jobs, point out quickly what that job involved or what it entailed. These are the changes that were pushed out to Leaf 2 in this case. Trust me on this, but this is causing AS path prepending in the underlay and EVPN route filtering in the overlay by virtue of a BGP community tag that says if you get this, throw it out. So any EVPN routes generated by Leaf 2 are now being discarded, and if there's any way to get there without using Leaf 2, that's the way we'll go because it's EBGP metric, the AS path has also been poisoned. And that's a good thing in this context, right? So with that said, now let me quickly switch back, and we're in the home stretch. I keep saying this, but let me do a request system reboot. The QFXs like to give you a minute's notice, so we've got about a minute left of this. Let me point out Leaf 1 is still pinging loopback to loopback. We expect these pings to fail once Leaf 2 reboots. Bare metal servers are still pinging. We expect these to continue to work because of the multi-home connectivity. We'll just give it a few seconds to complete. Now's a good time, I reckon, to say, are there any questions? All right, notice that we have indication Leaf 2 is in maintenance mode. It's not an active part of your fabric. Notice we support things like RMA, bringing additional devices on via a ZTP wizard. Here's the RMA buttons. See those buttons? RMA. All right, I expect Leaf 2 to finish its warning countdown. Give me 30 more seconds. It's very dramatic. This is the money shot, right? It would be like stealing from you if I didn't make you wait for this. Look at that, it's rebooted. Okay, so at this point, we expect the loopback to loopback pings to fail if I was pinging the right address. God, don't tell me I've stuffed that up now. So clearly, I'm not pinging Leaf 2's loopback address. That's weird. Oh, notice I put 250 for both. What did we say Leaf 2 was, by the way, from a loopback address? Well, it was 249, so I've really stuffed that up now. But had we have picked 249, we would see that those pings would be failing because leaf 2 is rebooting. All right. Meanwhile, back at BMS1, I'll stop those rapid pings, and notice not a single packet was lost, hence we call this hitless. So the reboot that I perform manually might well have been part of a Junos upgrade, a hitless fabric upgrade. And as a last thing I'd like to show, let me just do an IPA. Let's get the MAC address of bare metal server 1. There it is. We think this is a pretty useful functionality. I'm going to go back to my fabric. I'm going to pick all of the devices except for the one that we got in maintenance mode. Well, because it's rebooting, so we wouldn't want to mess with that, right? I'm going to run a device operation. You saw this earlier with the configuration diff. This time we're going to do an IP MAC lookup. We find many operators consider this quite useful. So basically we're going to say, go find that MAC. Tell me who's learning that MAC, where does it come from? Again, I exempted leaf 2 because it's currently rebooting right now. That would just force an unnecessarily painful delay on this whole process. Again, a somewhat pregnant pause, but we expect completion here. Boom, boom, boom. All right. So, according to the results, Spine 2 says that this MAC address is being learned on XE0010 on the device with loopback 250. I was pinging myself earlier, as you saw. It's something I generally don't like to do in public. And that's on leaf 1. And likewise, we have leaf 1 confirming the same thing, right? So basically, we are able to track down where a MAC address is being learned, on what port, on what TOR. So I believe, with this being said, it completes the planned presentation, which I've somehow dumped out of anyway, so I'll just leave it alone. So do we have any questions or comments?
I see that everything is automated, and you have the recipes for everything. So an engineer can also define his own workflows or recipes for doing something different than what you're doing, or everything is pretty much standard.
Well, it is programmable, so we could certainly have automation that does everything you saw via scripts and automation. I think I would argue once you're in the controller context, you are limited to the constraints of what the controller supports. And in like full honesty, right now our standard EVPN features tend to lag a little, or tend to run ahead of the controller-based solution, meaning there are things you can do with the CLI that we don't yet support with the controller. So in that regard, if you're interested in making your own recipes, you might be better off not going with a controller and having full control over what you're baking and when you consider it done. But it is a flexible solution. So within the constraints of what we support, you could alter these workflows to some degree, or like we said, allocate a domain to a client or a tenant and let them cook their own cookies while you're busy doing what you want to do.
One of the questions I have is when we go through graphical user interface, it abstracts out a lot of the engineering that goes behind the scenes. What happens when something inevitably does go wrong and there is an error? Is there a way to dive into that to be able to?
Good question.
What it does is it abstracts the errors away as well, but instead I want to dive in deeper and figure out what is going on.
Okay, very good question. So a few things. As you saw, we have this job management where we report that jobs are scheduled and whether they succeeded or not. So if the job succeeds, but somehow there is still an error, whatever that might be, which would be, I would assume, a relatively rare event, that could be pretty tricky. But if the job fails, then you'll get an indication it failed. And as you saw, you can quickly link to the log and see what tried to happen as well as the error response that was received. The other thing, and this may be a bit beyond your initial question, but the controller itself is out of band. It's not in the data path of the traffic. It is stateless in the sense that you give it a task, do this on this leaf. That task is scheduled, the job is pushed out. Again, we give you completion status and the ability to look at the logs. Once that task completes, the controller's done. So should the controller fail, your data center operates just as it was before the failure, meaning you're no worse off than somebody who opted for a controller-less solution at that point. Whatever state was in your network remains, the forwarding state remains. The problem might be that because you opted for a controller, maybe you reduced your operations staff because the controller makes it so easy, and maybe you opted not to train or learn how EVPN operates, which means, I think what I'm trying to say is, if you're the kind of customer that goes controller-less, you probably have the on-site expertise ready to go when something happens. Whereas if you go with the controller solution, it's possible you might have to bring in help, because the whole point of the controller is to abstract away that complexity, allow you to reduce staffing and possibly training. Now, as James mentioned, we'd always recommend that you know how your network operates and that you maintain some level of expertise. But worst case scenario, you've lost the controller, the network operates as it was, and you can pick up the phone and call somebody to help.
Okay.
Yeah?
So we got a question on whether or not the controller can provision multi-site fabrics.
It can. We support multiple fabrics. We support data center interconnect across those fabrics. We also support multi-cloud connectivity, as you might have guessed, given the name multi-cloud.